Alright, so the next few graphs are going to be decay graphs. So remember, for decay graphs, the base has to be a fraction between 1 and 0. These bases are never going to be negatives. I'll kind of talk about what a negative base does, but negative bases aren't going to look like this. Okay, so over here, this time the base is a half. So half, 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 half. And these are my exponents again. So I'm going to square a half. So when I square a half, I square 1 and I square 2. So 1 squared is 1, 2 squared is 4. Here I'm going to put this to the 1 power. Anything to the 1 power is just itself. And here anything to the 0 power is always 1. So for the negative ones, here if I make this go to the negative 1, remember negative exponents flip the fraction. So if it's already a fraction, it's going to flip it to 2 over 1, which is just 2. So these are always reciprocals of each other. These come in pairs. They're going to be reciprocals of the number. Again, if you don't shift it. Once you shift it, that's not true. But here on the parent function, these are reciprocals of each other. So here, if you make this one go to the 2nd power, you flip it around and you get 2 over 1. 2 over 1 squared, 2 squared is just 4. So here you start at -2, now you start up at 4, and it's going to go down because it's decaying. So -1 is at 2, 0 is at 1, 1 is at a half, and 2 is at a quarter. So the horizontal asymptote is still the x-axis here, which is y equals 0. So you're going to start high this time, and since it's decaying, it's going to get closer to the x-axis this way. So it's going down, it's decreasing from left to right. You still have the y-intercept at 0, 1. And then a couple other things I didn't mention on the other one. You will have this point as well, which is the number, the base. So at 1, it's the base. So 1 and whatever the base is. And then over here, at -1, you're going to have the reciprocal of the base. Okay, so those are some other points that will be on the graphs. Those are the 3 you want to kind of plot, if you can fit them. More than likely you can fit those 3 for sure. These other 2 might be too big or too small. Okay, but the domain is still all real numbers. And the range is still the horizontal asymptote. So here it's going to be y is greater than 0. It's only less than if it reflects down here. If it reflects and goes downwards, then it's going to be less than 0. Okay, so for this one, I am going to, again, show you how to type it in the calculator, but then we'll come back and fill in the tables as need be. Alright. So this one, oh, it starts off with a tricky one. Okay, so let me come up here. So looking at the transformations, here the base looks like it's a growth. So this 2 here, this 2 as the base, tells us that it should be growth. But because the exponent's negative, this is going to make it reflect over the y-axis. I'm going to put that over here, reflects over the y. This actually turns it to decay. And then the 3 in the front is going to vertically stretch it by 3. If you think about this part, 2 to the -x, the negative, remember, makes the reciprocal of the base. So instead of writing it like this, I can actually write it as the reciprocal of 2 is a half, and that's to the x power. So a negative exponent just does the reciprocal of the base. That's why it changes it from growth to decay or decay to growth. So here what we're actually going to graph is 3 times 1/2 to the x, which is the same thing as this up here. Okay, so but this one is decay because it's a fraction. So this is the one I want to type in the calculator to get the points. Actually, before I do that, I want to show you how to just, in your head, get these 3 points. So you know the 1 is the y-intercept. So here, anything to the, the 0, anything to the 0 power is 1. But then I'm going to take that, I'm going to multiply it by 3. So my y-intercept is going to be at 3. For this one and this one, 1 is at the base, which is 1/2. And 2 is at the reciprocal of the base, which is 2. But then I have to multiply each of those by 3. So here, 1/2 times 3, 1/2 of 3 is 1.5. And 2 times 3 is 6. And really, those are the 3 points you need. The other ones may or may not fit, but as long as you can get 3 points, that's good enough. But over here, if we come, I can get the other ones. But it might be easier in some cases to just do it in your head. So the middle one is your y-intercept, and you multiply it by the a value. This is the base, and this is the reciprocal. But coming over here, I'm going to do 3 times 1/2. So in these calculators, you don't need parentheses around it because it does the stacked fraction. But if you don't do the stacked fraction, you do need parentheses when you divide. So to the x power. And we're going to graph it. So again, notice how it's a decay. It's going down from left to right. And then to get the rest of the numbers, we just go Control-T. And I want 0 in the middle because that's what k is. Or sorry, that's what h is. There's no number up there. So I know 0 is at 3, or sorry, 0 is at 3, -1 is at 6, -2 is at 12. And if I go any further than that, I can't fit it anymore. So again, whatever h is goes in the middle. And then +2 is 0.75. So at -2 it's 12. At -1 it's 6. At 0 it's 3. At 1 it's 1.5. And at 2 it's 3/4. Okay, so make sure you do your horizontal asymptote. So again, since there's no k number out here, it's like it's a +0, which means my asymptote is y = 0. So draw your dashed line at the x-axis. So your graph is going to start high, because its decay is going to start up, and then go down from left to right. Make sure you extend it past the plane. Okay, so here, the range, it's still above, the graph is still above the asymptote, so we say it's greater than 0. Only when you reflect it underneath the asymptote is it less than. And the range, and the domain is still all real numbers. This is not going to change. All right. So again, knowing how to get these points, this value always gives you the y-intercept. So whatever the 0 point is, that's going to be your a value there. Whatever this number is, that's your a. And then whatever it's going up by each time, whatever you're multiplying by, that's your b. So here times 2 times 2, just like we did in sequences, means that the base is 2. But it's going downwards because it's decay. Alright, so if we look at the next one, again, it wants the transformations, and the graph, and the asymptotes. So here for this one, let's see if we can do the table without the calculator. So this right here tells us that it's a growth, or sorry, not growth. It is going to be growth, just not yet. So it tells us it should be a decay because it's less than 1. However, because it's a negative in the front, this tells me to reflect it over the x-axis. Then it's going to change this to growth. It's going to make it go up from left to right. And then the 2 in the front makes it stretch by 2. Okay, so looking at the table. Okay, so looking at the table, I know 0 is going to be anything to the 0 power is 1. Anything to the 1 is itself, so this is going to be a fourth. -1 is the reciprocal of this, which is +4. And then for 2's, we just square the numbers. So here we square 1. 1 squared is just 1. 4 squared is 16. And then this one's the reciprocal of it. So these always come in pairs for the tables. But this is just the 1/4 part. Then I have to multiply it by the -2 in the front. So times the -2 times the -2 times -2. So this one ends up being -32, which I'm not going to be able to fit. This one is -8, which I can fit. This one is -2. -2/4 is just -1/2. And then here, -2/16 is -1/8. Which again, I'm probably not going to fit that one because that one's going to be too small. But as long as I have these three. So at -1, it's -8. At 0, it's -2, which again is your y-intercept, that's your a value. And 1 is at 1/2. If you want to put the 2 at 1/8, that's just going to be like super small right there. But that's all we can get. Okay, so always do the asymptote first. The horizontal asymptote is the k, which there is no k here, so it's like it's a 0 out there. So y equals 0 is your k. We have a horizontal line there. So what's going to happen here is it's going to start low and go up, but then flat, ooh, that's ugly. Then flat line at the asymptote. So I'm going to go this way. So go this way. Pretend that hit it. And then this part's going to go flat here. So again, that's why it's growth, because it starts low, then it goes up from left to right. So here, what's the range? So we know it's a y and a 0, because the 0 is the asymptote. But because it was reflected underneath the asymptote, this is when it's a less than. So less than 0, but not equal to, because it's never going to cross it, never going to touch it. And the domain is all real numbers. So again, you could type it in the calculator to get the table. So here I've already typed it in. If you do Control-T, you'll get the actual decimal values. Just make sure 0's in the middle. But we were able to get these numbers. So -0.5, -1/8 is -0.125 without typing it in. Sometimes it takes more work to type it in. Alright, and then we have one more graph over here. And this one I am going to type in for this equation. So here, the +4 tells us that it goes up 4. And we can already come over here and say the asymptote. So we know the asymptote is going to be at 4. The 2 as the exponent, the -2, tells me that it goes to the right 2. The 1/2 tells me that it's a growth, because that's the base. And the 3 in the front tells me that it stretches by 3. Okay, so we're going to type all of this in the calculator and get some points for the graph, and I'll come back and I'll show you how to get some points without the calculator. But this one, since we are shifting it, might be easier just to type it in. Okay, so here's typing it in for this one. Here's the equation, so we look at the table. Again, we want points that are around the h value. So you put h in the middle. Quit doing that. So h is x minus 2, so we want to put positive 2 in the middle. So then we're going to do 3, 4, and 1, 0. So that'll ensure that some of those points will be able to fit. So here, 2 in the middle is at 7, then 10 and 16, 5.5 at 3, and 4.75 at 4. Okay, so before we start graphing points, let's graph the asymptote. So the asymptote is going to be at 4. That's my flat line. And then I graph 0 is at 16, 1 is at 10, 2 is at 7, 3 is at 5.5, and 4 is at 4.75. So just above, or just a little more than halfway. And so again, this one starts high since it's, why did I put growth up there? Sorry. Sorry. This is decay. This is less than 1. So it starts high and it goes down from left to right. So again, the range is always the asymptote. And since it's above the asymptote, it wasn't reflected. It's going to stay greater than. And the range is always, x in the real numbers. Okay, real quick, I'm going to show you how to just get from here to here without going through the calculator. You can get these 3 points easily without going through the calculator. So here, we know 0 is always 1. Because anything that 1 power is, or anything that 0 power is 1. But then we have to multiply by the a, which is a half. Or sorry, the a, which is 3. So we multiply this by 3. And we get, so times by 3, and we get 0, 3. So right now we're at 0, 3. So if we go to 0, 3, that's this point right here. But then we know we have to move it right 2 and up 4. So right 2, up 1, 2, 3, 4 takes us to this point, which is the 2, 7. Okay, so right 2 means we add 2 here. Up 4 means we add 4 here, which gives us 2, 7. Okay, so that's how we would do it without using the calculator. But again, for now, we can just use the calculator to get those points. Alright, so the last part at the bottom, these are going to be kind of deciding what's happening here. So I give you a sketch of the graph, and you got to tell me some information about them. What do you know about A, about B, and about K for these graphs? So I'm going to go in order of easiest to identify. So I'm going to start with the K's. K, remember, is your horizontal asymptote. It's where your graph flatlines. So if I look at the first example, it's going flat right here. So this means that my K value needs to be above the x-axis. So here K is more than 0. And I would say because the horizontal asymptote is above the x-axis. Okay, so if we look at B, where's the horizontal asymptote for this one? Well, it goes flat here, which is below the x-axis. So here, this one's going to be a negative number because the horizontal asymptote is below the x-axis. And then the last one here, it flatlines on the x-axis. So if it flatlines on the x-axis, then it's 0 because the horizontal asymptote is the x-axis. Okay, so that's the easiest one to identify. The next one to identify, so B is your base, and A is your reflection or not. So here, if we look at the B first, actually, let's look at the A. So A determines if it's reflected or not. So reflected. If it's reflected, that means that the graph itself is going to be either above or below the x-axis. Here, since it's above the x-axis, it's not being reflected. So I can say it's positive because it's not reflected. It's not, or because it's above the x-axis. Here, still above the asymptote. Yeah, so it's not being reflected again. So maybe not above the x-axis, but above the asymptote. So here, this one's still above the asymptote. So A is still going to be positive because it's above the asymptote. So I like that one better than not reflected because it's above the x-axis, or sorry, the asymptote. But if you look at this last one, this one is below the x-axis. So if it's below the x-axis, we know it's being reflected, so it's negative because it's below the asymptote. And in this case, the asymptote happened to be the x-axis. But you always compare it to the x-axis. Or sorry, to the asymptote. I keep saying x-axis. You always compare it to the asymptote. Is it above or below it? Okay, so then finally we can say if it's growth or decay. So here, since it's going up from left to right, we say it's growth because the base is greater than 1. So base is greater than 1 because it's a growth. It's increasing from left to right. Here, this one starts up, but it goes down, so it's decreasing from left to right. So that means it has to be a fraction, less than 1, because it's decay. Now this one we got to be careful with. Looking at the graph, it's going down, so this one is decay, but remember it was reflected. So if I unreflect it, that means it's going to be up here, which means it would be a growth function originally, but then I reflected it to make it decay. Okay, so here the base is greater than 1 because it's a growth that was reflected. So that's what turned it to a decay. But you have to undo that operation here. Okay, so this is just being able to analyze the graphs. So we're not going to be graphing them physically, but you will have to be identifying the transformations and the asymptotes for these problems.